Hi, my name is Daria Wilk, and I'm going to be talking about the impact of biofuels from algae on global warming. What is global warming? Global warming is a gradual increase in the overall temperature of Earth's atmosphere, generally attributed to the greenhouse effect caused by increased levels of carbon dioxide, chlorofluorocarbons, and other pollutants. How much do you think global warming has progressed in the last few years? Looking up global warming progression, many results come up about the increased evolution of global warming. Temperatures have climbed 1.4 degrees Fahrenheit around the world since 1880. What contributes to global warming? When burning biofuels, which is hydrogen and carbon, it produces carbon dioxide, which contributes to global warming. Although biofuels produce less GHG emissions than fossil fuels, that only slows down global warming. Biofuels are just one part of a range of alternatives for lessening greenhouse gas emissions. There are many cost-effective solutions that reduce emissions from deforestation, land degradation, and different forms of renewable energy. The impact of biofuel production from algae on global warming is quite alarming. Algae is relatively high in density with low needs for fertilizer and pesticide, and with most of the energy input being derived from the sun. Experiments show that algae requires a lot more energy and can be derived from harvesting it. There are many assumptions and theories about algae that can be an alternative for biofuel feedstock. People can help stop global warming by finding alternatives to biofuels such as microalgae, creating low inputs of fossil fuels and chemicals, making sure biofuels are sustainable, recognizing the impact of greenhouse gases, failure to count carbon emissions and the worldwide agricultural model, finding alternate energy sources and products processed into biofuel, and recognizing the cost per gallon and years of biofuel factors. Although the use of microalgae is a suitable alternative feedstock for future general biofuels, certain species contain high amounts of oil which can be processed and refined into transportation fuels. Microalgae has a fast growth rate. They warrant the use of non-arable land and non-potable water, use less water, and don't move food crop cultures. Neochloris, oleabundans, freshwater microalgae, nanochloropus, and marine microalgae are proven to be fit as raw materials for biofuel production. Their high oil content makes them suitable as an alternative to biofuels. Microalgae is not only suitable as a raw material for biofuel production, but they also have low inputs of fossil fuels and chemicals. Governments all around the world promote the development of biofuels in order to alleviate the climate impact of using fuels. Biofuels are produced from crops using conventional agricultural practices. Natural oils from plants like oil, palm, soybean, and algae can be burned to produce fuels such as biodiesel. The impacts of biofuels on climate change, water use, and land use can be very harmful. Policies should promote the development of sustainable biofuel programs that have very low inputs on fossil fuels and chemicals that rely on rainfall or abundant groundwater and that use land with little or no economic or ecological value in alternative uses. Not only do biofuels have low inputs of fossil fuels and chemicals that rely on rainfall or abundant water, but biofuels also have to be sustainable. Biofuels and biodiversity are a new priority in efforts to reduce the need for fossil fuels. There are many guidelines that biofuel feedstocks need in order to be sustained. Biofuel feedstocks should be grown with environmentally safe and biodiversity-friendly agricultural practices. The ecological footprint of a biofuel, in terms of land area needed to grow sufficient quantities of the feedstock, should be minimized, and biofuels that sequester carbon or that have a negative or zero carbon balance when viewed over the entire production life cycle should be given a high priority. The sustainability of any biofuel feedstock depends on good growing practices and sound environmental practices throughout the fuel production life cycle. The ecological footprint of a biofuel shows that the best alternatives are for fuels for the future, especially microalgae. Biofuels that sequester carbon that show negative or zero carbon balance and show that corn-based ethanol is the worst among alternatives that are available at present. Corn as an alternative to a biofuel feedstock is an aggressive pursuit. Greenhouse gases, the failure to count carbon emissions, and the worldwide agricultural model are also very important to the impact of biofuel from algae on global warming. Substituting biofuels for gasoline will reduce greenhouse gases because biofuels sequester carbon through the growth of the feedstock. Failing to count carbon emissions show that the analysis that occur as farmers universally respond to higher prices and change forest and grassland to new cropland. Scientists use a worldwide agricultural model to estimate emissions from land use change. They found that the corn-based ethanol nearly doubles greenhouse emissions over 30 years and increases greenhouse gases for a period of 167 years. These statistics raise concerns about biofuel and highlight the value of using waste products such as algae for biofuel production. Not only are greenhouse gases reducing biofuels for gasoline, but alternate energy sources and products processed into biofuel are also key components. Biofuels from microalgae need technologies for production, processing, and extractions of biofuels and co-products. The key principle in natural resource management of biofuels from microalgae is sustainability. Sustainability involves operational efficiency, minimization of environmental impact, and socio-economic considerations. The reliance on fossil fuel energy resources is unstable, which makes algae a biofuel that needs to be sustainable. Alternate energy sources that are similar that are also from terrestrial crops are sugarcane, sugar beet, maize, and rapeseed. However, that places an enormous strain on world food markets, contributes to water shortages, and precipitate the destruction of the world's forests. Although the use of algae as a biofuel is a great alternative, there is a concern over competing land and changes. Microalgae are photosynthetic microorganisms with simple growing requirements. These can produce lipids, proteins, and carbohydrates in large amounts over short periods of time. This shows that microalgae would be a great alternative to biofuels. These products can be processed into biofuels and valuable co-products. The study shows that technology behind microalgae to biofuel systems, harvesting conversion technologies, and extraction of useful co-products. Microalgae propagation with carbon sequestration and wastewater treatment are for mitigation and environmental impacts associated with energy conversion and utilization. This shows that biofuels from microalgae need technologies for production, processing, and extractions of biofuel and co-products. From this figure, the red line shows the combination of factors that is expected to be required for algal fuels to become cost competitive with petroleum. The green line shows the limited petroleum supply, resulting in increased costs, and the blue line shows the business as usual scenario. Each circle shows the improvements that will require years of research and cover. The purple circle marked A shows bioprospecting for high oil production, low input requiring species. The blue circle marked B engineers the improved growth, harvesting, and nutrient recycling. The yellow circle marked C shows further strain improvement through breeding, selection, and random mutagenesis. The last circle marked D bioengineers to improve fuel traits, produce co-products, and crop protection. This figure shows that bioprospecting has a high potential to identify a solid biofuel species in the next few years, but subsequent improvement of that species, as well as solving engineering challenges to improve cost efficiency, will not occur rapidly. From these articles, you can see that biofuel feedstock requires water, fertilizer, pesticides, and land preparation. From the different alternatives given, algae would be the best option. Corn and soybean require more energy that could never be derived. Algae's relatively high density with low needs for fertilizer, pesticide, and the most energy from the sun shows how great of an alternative algae is for biofuels. From research, it shows that algae is the best alternative for biofuels for the impact of global warming. There is a lot of work that needs to be done and technology that needs to be produced to replace algae as a biofuel. Everyone can help stop global warming by finding alternatives to biofuels such as microalgae, creating low impacts of fossil fuels and chemicals, making sure biofuels are sustainable, recognizing the impact of greenhouse gases, the failure to count carbon emissions, and the worldwide agricultural model, finding alternative energy sources and products processed into biofuel, and recognizing the cost per gallon and years of biofuel factors. Global warming is a continuous cycle that will not stop with one person. Using these alternatives will decrease the mass of land that global warming is affecting.